then modules are working properly or not. In this we are checking modules are almost never integrated in one shot. We have to check all the modules are not to be integrated in the one shot. We have to collect them by following up step by step method. During each integration step, the partially integrated system is required to be tested. That is a simple specification of the integration and system testing. Regardingly, we have 4 modules available: M1, M2, M3 and M4. In the previous one phase, that is the coding and unit testing, we are writing down code individually for the N1, individually for the M2, individually for the M3, individually for the M4. After the writing of the coding of the different modules, there is M1, M2, M3 and M4. We have to test M1 independently of the M2, independently of the M3 and M4. Likely in the same way, M2 is to be tested independently of the M1, M3 and M4 phase in the unit testing. But when we are talking about the integration testing, we have to check the integration when the M1 module is calling the M2 module and that unit tested separately, that integration is working correctly or not. We have to check whether the M1 module is passing the correct data to the M2 module or not. In the same way, we have to integrate the different modules all together, likely by following up one by one. That is in this one phase, that is not required to be, we have not to integrate all the modules in the single step. We have to integrate the different modules by following up the step by step method. System testing. After all the modules have been successfully integrated and testing, we have to follow up the system testing. System testing, the goal of the system testing is to ensure that the development system functions according to its requirements as specified in the SRS document are working or not. The goal of the system testing is to test whether the system as a whole is working properly or not. In the system testing phase, there are basically 3 methods for specifying for making up the system testing, that is the alpha testing, beta testing and acceptance testing. Alpha testing is there is the different method. Regardingly, the alpha testing is carried out by the development team. The beta testing is carried out by the friendly group of customers, and the acceptance testing is carried out when the system or software is supplied to the customer. At that particular time, the customer is testing, customer is checking whether the system is working according to its requirement as specified in the SRS document or not. If the system is working accordingly, then the customer is accepting that particular system, otherwise it is rejecting that system. In the testing phase, there is also the 2 different kind of testing that are known as the white box testing and black box testing. White box testing, in the white box testing, we are only checking the, in the black box testing we are only checking the outer environment of the system, whereas in the white box testing we are checking up the whole system. The next one phase of the software development life cycle is the maintenance phase, that is required the maximum effort. Regarding, we can say in the all previous phases there are only 40% of efforts are required, but in the maintenance phase there are approximately 60% effort are required. Maintenance of the any software product require much more efforts than the effort to develop the product itself. Development effort to maintenance effort is typically proportionate as to 40:60 ratio. Likely in the development efforts are requiring only a 40% of the total effort, and maintenance phase is requiring with the 60% phases, 60% efforts. The maintenance phase, the maintenance of the system is also categorized into 3 different categories. The first one is the corrective maintenance, second one is the perfective maintenance and third one is the adaptive maintenance. Corrective maintenance is to correct the errors which were not discovered during the product development phase and the testing phase, that is to simply correct the different kind of errors available in the system. That particular maintenance is known as the corrective maintenance. Second one maintenance is known as the perfective maintenance, that is to improve the implementation of the system or to enhance the functionality of the system. Perfective maintenance means to add up the new functionalities in the already available system. Perfective maintenance is known as to adding the new functionalities in the already available system that are not previously available in the SRS document. The next one is the adaptive maintenance. Adaptive maintenance is to port the software to the new environment, that is to likely we are saying regarding our software is already capable of only running on the Windows system and we have to sorry. Adaptive maintenance means to port the software to the new environment. Likely if the software is capable of running on already on the Windows environment, in the adaptive maintenance we are providing to shift that particular software to make it capable to run also on the Linux environment. That is the adaptive maintenance, to making it to run on the new environment, to making it to new computer or into the new operating system. That is all about of the first one, what a model of the software development life cycle, that is the classical waterfall model. Now there are a number of disadvantages of that particular model. For that reason, the further models are defined for the software development life cycle. The next one model is the iterative waterfall model. In the classical waterfall model, the main disadvantage of that one model is the thing is that if the any defect or any problem arises in the next one phase, likely if we take the example, when we are making when we are writing down the code, we have finding out that there is some problem in the design phase, and if we when we are following up the design phase, we are finding out that there is somewhat problem in the previous one phase, that is the SRS phase. Then there is no method on the to go backward. In the classical waterfall model, there is only method to go forward, there is no method to go backward direction. If we are finding out in the future, if we find it out there is problem in the requirement specification or in the design, then there is no method to go on the previous one. We have to design that particular software from the zero level. That is the main disadvantage of the classical waterfall model. It assumes that there is no defect is introduced during any development activities. In practical environment, there is a number of defects get introduced in almost every phase of the life cycle. For that reason, there is some step, there is some method to be available for going from the next one phase to the previous one phase. That defect usually get detected much later in the life cycle. For example, a design phase defect might go unnoticed till the coding or testing phase, but when the defect is noticed in the classical waterfall model, there is no method to go into the previous one phase. For that reason, the next one model is provided in the system, that is the iterative waterfall model. That model is providing you the method with going to the previous one phase once a defect is detected. Once a defect is detected in the system, we need to go back to the previous one phase where the defect was introduced, and it to be required to be redo some of the work done during that phase and all the subsequent phases. Therefore, we need feedback path or a backward path in the classical waterfall model. That particular backward path is provided in the iterative waterfall model as specified in the diagram. Here we will see that in the classical waterfall model only the forward arrow is available, but in the iterative waterfall model there is almost from every phase we can go to the any another phase. Likely if the during the testing phase, we will find out that there is some problem in the requirement analysis and specification phase. There is a path available for going to the from the testing phase to the requirement analysis phase. After going to the requirement analysis and specification phase, that we have to will do the required changes and then follow up those particular changes in the further ones steps, that is design and coding phase. In the iterative waterfall model, errors should be detected in the same phase in which they are to be introduced. For example, if a design phase problem is detected in the design phase itself, the problem can be taken care of much more easily than say if it is identified at the end of the integration and system testing phase, that is required with too much effort required from the software development team. That particular system is known as the software containment of errors, phase containment of errors. A phase containment of errors specifies rework must be carried out not only to the design but also to the code and test phases. The principle of detecting errors as close to its point of introduction as possible is known as the phase containment of errors. That particular facility is provided also by the iterative waterfall model. Iterative waterfall model is by far the most widely used model in the today environment. Almost every other model is derived from the waterfall model. In the classical waterfall model, irrespective of the life cycle model actually followed, the document should reflect a classical waterfall model of the development. Comprehension of the document is facilitated. The next one model is the prototyping model. In the prototyping model, before starting the actual development of the system, a working prototype of the system should be built up first. A prototype is just the toy implementation of the system, it is just the to developing the system that is of the limited functional capability, low reliability and inefficient performance. The prototype model is followed up in the environment where the customer is also not known about its exact requirements exactly. Reasons for developing a prototype model is to illustrate to the customer that input data format, messages, report or interactive dialogues. Regarding in the prototype model, we are supplying to the customer a simple prototype, a simple small kind of software to the user, to the customer, and then saying it to work on that particular model and to say that particular model is working properly or not. If that is not working properly, then to dump that particular prototype, or if that is working okay, then to further do some changes in that particular prototype and do the further model and show it to the user, and this way we are making our software. In the prototyping model, examining technical issues associated with the problem development. The third one reason for developing a prototype model is it is always impossible to get it right at the first time. We must plan to throw away the first product if we want to develop a good product. That is a basic concept behind the prototype model. In the prototype model, we will start with the approximate requirement, because we are saying in the prototype model we are using in that cases when the customer is not specifying not also exactly clear with the exact requirement of the requirements. In the prototype model, then we will start with the approximate requirements. Carrying out the quick design, prototype model is built using following up different shortcut methods. Shortcuts methods involve using different inefficient, inaccurate or dummy functions. A function may use a table lookup rather than performing the actual computation in the prototyping model. The developed prototype is submitted to the customer for its evaluation. Then after the evaluation of that particular prototype, customer is providing its feedback. Based on that particular feedback, requirements are then redefined. This cycle continues until the user approves the prototype. The actual system is developed using the classical waterfall model in the prototyping model. That is the simple method of the prototyping model. Regardingly, the some simple approximate requirement are specified in the prototyping model. Then we are following up the quick design. After the quick design, we are building the simple prototype. That particular prototype is supplied to the customer for its simple evaluation. If the customer is not specified, then we are changing the simple requirements. Then after the refinement of the requirements, quick design is made up, and then following up the same method, prototype is built, and again the prototype is supplied to the customer for evaluation purpose until the customer is satisfied. After when the customer is satisfied, then we are saying that our design is okay. When the design is okay, the further steps are followed in the same manner as in the classical waterfall model. After the design, there is implementation, then the testing, and then the maintenance. In the prototyping model, requirement analysis and specification phase becomes redundant. Final working prototype with all user feedback serve as the animated requirement specification in the prototyping model. Design and code for the prototype is usually thrown away. However, the experience gathered from the developing the prototype helps a great deal while developing the actual product of the system. Even through the construction of the working prototype involves additional cost in the overall development of the system, but in that particular model, system is cleared with the user's requirement and all the technical issues are resolved in the prototyping model. Many user requirements are to be get properly defined and technically resolved in the prototyping model. That is a basic benefit provided by the prototyping model. After the prototyping model, the next one model of the software development life cycle is the evolutionary model. Evolutionary model is also known as the successive version model or the incremental model. In the evolutionary model, the system is basically broken down into the several modules which can be incrementally implemented and delivered to the system. In the evolutionary model, we firstly develop the core module of the system. The initial product skeleton is refined into the increasing level of capability by adding new functionality into the successive version of the system. The successive version of the product functioning system capability of performing some useful work. A new release may include new functionality. Also, existing functionality in the current release might have been enhanced in the successive version of the system. Likely, that is the diagrammatically specification. We are firstly specifying to the user a simple model A. After the supplying of the A model, we are adding some new functionality to the system and supplying the new system model to the user, that is B, and then adding some new functionality, that is the model C. Likely, this evolutionary model is used when the customer is required with immediately the development of the system. When the customer is not available with time, then we are supplying to the user some of the basic need of the users. After the basic need of the users are satisfied, we are then providing them the incremental model. In the advantage of evolutionary model is to users get a chance to experiment with the partially development system much before the full working version is released. It also helps finding exact user requirements very easily much before fully working of the system is developed. In this system evaluation model, the code modules get tested thoroughly, reduce the chances of errors in the final product. The disadvantage of the evolutionary model is it is very difficult to subdivide the problem into the functional unit which can be incrementally implemented and delivered. The evolutionary model is useful only for the very large problem where it is easy to find the modules for incremental implementation. The main problem in the evolutionary model is to subdivide the problem into the functional units. In the evolutionary model, many organizations use a combination of iterative and incremental development. A new release may include new functionality, and existing functionality from the current release may also need to be modified. In the evolutionary model with iteration, the different advantages are that training can start on the earlier release, market can be created, frequent releases allow the developer to fix the unanticipated problems quickly. The last one model in the software development lifecycle model is the spiral model. That the spiral model is proposed by the Boehm in 1988. Each loop of the spiral represent the phase of the software process. The innermost loop might be concerned with the system feasibility. The next one loop is deals with the system requirement specification. The next one loop specify the design. The next one is the implementation, and so on. There are no fixed phases in this one model. The phases shown in the figure are just example that depend on the particular software development team to number of phases followed in the for the design of the system. The team must decide how to structure the project into the phases. We have to start work in the spiral model using some generic model, add extra phases for specific project or when the problems are identified during the project. Each loop in the spiral is split into the 4 sectors or quadrants. The first one sector is for determining the objective, the second one is to identify and resolve the risk, the third one is to develop the next level of product, and the fourth one is for the customer evaluation of the prototype. The innermost spiral of the system is known as the feasibility, then the software requirement specification, then the design, then coding, and then the system testing, and so on. The number of loops or number of spirals can vary from one system or one software to another software. In the first quadrant, the main objective is to identify the objective of the phase, to examine the different risks associated with the different objective. The risk deals with the particular objective can be the any adverse circumstances that might hamper the successful completion of the software project. In this quadrant, we have to find alternate solutions available for the system. The second one quadrant, that is the risk assessment and reduction, in as the different risks are identified in the first one quadrant. In the second one quadrant, we have to assess and reduce that particular risk. For each identified project risk, a detailed analysis is to be carried out. Steps are taken to reduce the risk. For example, if there is a risk that the requirements are inappropriate, a prototype system may be developed. In the spiral model, development and validation is the third quadrant. In that quadrant, we are specifying the develop and validate the next level of product. The last one quadrant of the spiral model is the review and planning. In that particular quadrant, we are reviewing the result achieved so far with the customer and plan the iteration around the spiral. With each iteration around the spiral, progressively more complete of the version of the software gets built in the spiral model. Spiral model is also known as the meta model because these provide the these models follow up the all previous models. It subassume all the discussed models. A single loop spiral represents the waterfall model, uses an evolutionary approach. Iteration through the spiral are evolutionary levels, enable understanding and reacting to risk during each iteration during the spiral, uses prototyping model as a risk reduction mechanism and retains the stepwise approach of the waterfall model. For this reason, this model, spiral model, is also known as the spiral model because this providing the mechanism used in the all previous kind of models. As we have discussed about the different models of the software development lifecycle models, now we will follow up a simple comparison of the different models used in the software development lifecycle likely in the different models we have discussed about. Those are the classical waterfall model. In that model we are specifying different phases, likely the requirement feasibility phase, analysis phase, requirement analysis and specification phase are following one phase to the another phase. The second one phase is the model is the iterative waterfall model. In the iterative waterfall model, we are providing the backward path to the previous one phase. In the prototyping model, we are supplying the working prototype of the model to the users. In the fourth one model, prototyping model, evaluationary model, we are making the system by following up the incremental process. That particular evaluationary model is also known as the incremental or successive version model. And at the last, we have discussed about the spiral model. That particular model is also known as the meta model. That model followed up the or used the specifications or methodologies of all the previous discussed model as the classical waterfall model, iterative model, prototyping model and evaluation model. In the iterative waterfall model is the most widely used model in the today environment, but suitably only for the well understood problems. This model is used. Classical waterfall model is very rarely used because of its disadvantage. It cannot be used because from one step, from one phase, there is no proper method from following up the second one phase to the previous one phase. In the iterative waterfall model is the most widely used model, but only for the well understood problems. Prototype model is suitable for the project not well understood. When the customer is not clear with the requirements, then we are using with the prototype model when the user requirement and technical aspects are not clear. The evaluationary model is suitable for large problem but only for those problems that can be decomposed into a set of modules that can be incrementally implemented, or incremental delivery of the system is acceptable to the customer. Only on those cases we are using the evaluationary model. In the evaluationary model is usually used for the very large problem, and before using the evaluationary model, the software development is required to check whether the different incremental the system can be developed can be decomposed into the different modules or not, and can the different decomposed modules, different sub modules can be incrementally implemented or not, and also there is requirement to be specified that whether the incremental delivery of the system is acceptable by the customer or not. At the last, there is the spiral model that is suitable for development of technically challenging software products that are subject to several kind of risk. The spiral model is also known as the meta model that is supplying the all kind of methodologies that is following of the that is followed by the different software development life cycle models, likely the classical waterfall model, iterative waterfall, evaluationary and prototyping model, that is used for only those kind of products when the number of risks are involved in the software development. That is the discussion about the different life cycle models of the software development models. Okay, thank you very much. Thank you.